So, our problem is a filled treasure chest with a mass of 375 kilograms, with a long rope tied around its center, lies in the middle of the room. A pirate wishes to drag the chest, but there's friction between the chest and the floor with coefficient of static friction 0.52. The angle between the rope and the floor is 30 degrees. Make a free body diagram and find the necessary tension required to just get the chest moving. So our knowns are right here, and our mass is 375 kilograms, and our degrees is 30 degrees. And we have our known equations here, which is force equals the mass and acceleration, and the static friction equals the coefficient times the normal force, which is from our reading. So first, we're going to draw the free body diagram. We have our axis here. This is the y, and this is the x. And our particle, which is the chest, has a known force of gravity, the normal force, the static friction, and the tension, which we're trying to find. And this degree is 30 degrees. And all we need to find is the x and y components. Okay. So the first equation that we know is to find the components, and the x component is the tension times the cosine of theta, and the y component is the tension times the sine. And we know that gravity equals the normal force plus the y component, and which means the normal force is the force of gravity minus the y component. And since the x component equals the static friction, which is the coefficient times the normal force, we know that the x component equals the coefficient times the normal force. And now we can plug this equation in times the force of gravity minus the y component. And now all we have to do is solve for t. I'm going to FOIL this out. And I'm going to move this all the way over here. And now you can factor out the t. And this is divided by here to the other side. So this is our equation to find the necessary tension. And now all we have to do is plug it in. So we have our coefficient, 0.52, times the mass, which is 375 kilograms, times the force of gravity, all over the cosine of 30 degrees, plus the coefficient times sine of 30. And if you calculate that all out, you will get 1,698.8 newtons, which if you use sig figs becomes 1,700 newtons.